Okay, find the value of k so that the area A is the area under the curve from 0 to k, and area B, so that's the area under the curve from k to pi. We could put that in as 180 if you wanted. Just make sure that you're on the right, on your calculator, that you're in the right units. So if you're using degrees, make sure you're in degrees. If you're using radians, make sure you're in radians. So might as well just, I think, maybe work in radians, but you know that pi is 180 degrees, so that's fine as well. Area under the curve, that's integration. So if that's my function, I need to show them that I know that area is about integration. So we're going to integrate from 0 to k, so this is area A, of the function so that's the area under the curve from 0 to k, so that's area A. That'll be the same as the area under the curve from k to pi. Okay, let's just start subbing in once we have integrated. Again, be very careful integrating. You need to know properly how to integrate a trigonometry function. That's not just a straightforward trigonometry function as it is in the integration page of your log table, so be very careful. When I was going through this with E, I would have said either learn off the rule or, work forwards and then see how you undo it. So to integrate sine of a variable goes back to minus cos of the variable. Now, but that's not just a variable, that's a variable over 2. So we're going to the sine goes back to minus cos, and this we need to divide by 2. Okay, if you're not sure why I'm doing that, you just need to go back and have a look at integrating your trig functions. That should be the same as, so again, we're going to integrate that. Now we can put in our plus c's, but they'll eventually cancel out on both sides, I think. So then we have sine integrates back to minus cos. So this is just the same. And this time we're going from k up to pi. Okay, so we're throwing in k. Minus when we throw in 0. Plus c. No, our c's will cancel, sorry. Okay, so our c's will cancel out there. That's fine. That should be equal to cos of, or minus cos of pi over 2 plus c. And then we throw in minus the cos. So we're throwing in the pi minus when we're throwing in the k. The cos of k over 2 plus c, which they'll eventually just cancel out. Just be careful there, minus minus plus. And again here, minus minus plus. So let's start figuring this out. We have the cos of 0 over 2 is just 0. Sorry, cos of 0. I'm going to go to my log tables page and even my calculator. Okay, so the cos of 0 is 1. So that's a half there. minus the cos of 0 is minus 1. There's that minus. So that minus and that minus, we're looking at a plus there. That should be equal to minus the cos of pi over 2. So what is the cos of pi over 2? It's 0. So minus 0, which is just 0, over 2, which is just 0. Minus by minus is plus the cos of k over 2 over 2. Let's multiply everything by 2. We end up with minus cos k over 2 plus 1 is equal to 0. I'm not going to put that in. The cos of k over 2. I'm going to bring this over. I've got 2 cos k over 2 is equal to 1. And now we are looking for k, so let's move the 2. So okay, so the cos of what gives me a half, and remember it has to be below 180. Okay, so the cos of something gives me a half, so that has to be below 180, our final answer here, k. So what's a half? Cos half, we are looking at 60. So that's 60, which means k is 120. And if you want to write it in degrees, fine, but since the question was asked in radians, I'm going to just transfer it back to radians. So we have 180 degrees is pi, so then k is 2 pi over 3.